This is a continuation of our study on dividing polynomials using long division. In the previous lesson, um, if you go back to the previous lesson, I want to remind you about this example here. So when we divided this polynomial by this polynomial using long division, we had this remainder. And remember, there was a certain way that you had to write your answer. And the way you had to write your answer was that you took the quotient, which is this, and then you added the remainder, which was negative 31, but you had to write it as a fraction. So negative 31 divided by the divisor, which was x plus 2. So, so you may want to go back and review that lesson. But what I want to make a point is this. So if you go back to this problem here, we saw that when we divided this polynomial by this polynomial, we had this. I'm going to go ahead and write out what we ended up with. So we ended up with this answer. So we had x squared minus 6x plus 14, and then plus the remainder with, plus negative 31 divided by x plus 2. Now, I just want to remind you, see this right here? Some students, and it's okay to write it this way, you could rewrite this as this, x squared minus 6x plus 14 minus 31 divided by x plus 2. So I just want to remind you that those two mean the same thing. Okay, now the point here is this. I just want to remind you about a couple of things. So if we did go back to that problem that I was mentioning earlier, let me just quickly find it. Remember, this is the quotient. So when you divide a polynomial, this is the divisor, this is the dividend, this is the quotient. Okay, so in this problem here, when you rewrote it, notice that this polynomial here, which is a quotient, was this part of your answer. All right, and then the numerator of your fraction is the remainder, and then the denominator of your fraction is your divisor. So notice this denominator is the same as this denominator, your divisor. All right, so a couple of words I want to remind you of. So first is this, the dividend. The dividend is this numerator here. Okay, that's your dividend. So the dividend is x cubed minus 4x squared plus 2x minus 3. All right. The divisor is the denominator. So the divisor is x plus 2. Now notice that when you rewrote it, when you wrote the answer, see, this is the remainder divided by the divisor. So this polynomial has to be the same as this one. So the divisor is x plus 2. The quotient, remember when you do the long division, this is the quotient. So the quotient's this polynomial right here. So the quotient is x squared minus 6x plus 14. And the remainder is, and remember the remainder, when you did that long division, the remainder is this right here. So when you can no longer bring down any other term, then this would be your remainder. So the remainder is negative 31. Okay? All right, now notice that the way we wrote this, the way we wrote the answer was this way. So notice that the um, well, before we do that, let me remind you about the way we check this. So notice that when you go back and we check the answer. So remember that the next part. So where we checked. So remember this was your answer. So you took your divisor, we multiplied it by the quotient. See the divisor multiplied by the quotient. So this times this plus the remainder has to give us the dividend. Okay. So I just want to remind you about that as well. So when you checked, we ended up with this. So we said it'll be the dividend, which is x cubed. See, this is the dividend. So we said x cubed minus 4x squared plus 2x minus 3 equals, and what we did was we multiplied the divisor by the quotient. So we said x plus 2 times x squared minus 6x plus 14, and we added the remainder. All right, so if you go back to that page, you'll see that's what we did. So we multiplied the divisor times the quotient plus the remainder. So we did all that product. Remember, that you had a binomial times a trinomial, so you had to use the distributive property. And so we combined like terms, and notice we ended up with the dividend. All right, and so that equals the dividend. Okay, so when you check, remember that that's what we ended up with. Okay, but what I want to make a note is this idea here leads to what's called the division algorithm. Division algorithm. Okay, so that leads to what's called the division algorithm. All right, so let's talk about the division algorithm. So remember in our discussion, so we have two polynomials. All right, so we remember this is a polynomial, this is a polynomial. And I'm going to, when we talk about the division algorithm, we're going to refer to those as polynomial functions. So I'm going to say, so we have two polynomials. Let's call this f of x. So if f of x and remember this, remember is your divisor. So I'm going to use d of x. So d for divisor. So if f of x and d of x are polynomials, right? So if f of x and d of x are polynomials such that, now remember in the previous lessons and previous courses, whenever you have a rational expression, your denominator cannot be 0. Remember that? Because that makes this undefined. Okay, so such that d of x is not equal to 0. All right, because remember we can't have a denominator of 0. So that's what this means right there. And remember we talked about degrees in previous lessons. So if you look at the polynomial in the numerator, so if you look at the numerator, the degree, since you only have one variable in each term, the degree would be the largest exponent that you see. So notice the degree of the numerator, so the degree of this polynomial is 3. In the denominator, the largest exponent you see is 1, x to the first. So the degree here is 1. So the degree of the numerator is 3, the largest exponent. The degree of the denominator is 1, the largest exponent. Now remember, each term only has one variable x, and this is your constant. All right, so keep in mind that whenever you have a polynomial that looks like this and looks like this, the degree would be the largest exponent that you see. Okay, so again, the degree of the numerator is 3, the degree of the denominator is 1. All right, so and the degree of the numerator, f of x is greater than or equal to the degree of the denominator, so of d of x. Okay, so notice that in this case, the degree of the numerator, which is 3, is larger than the degree of the denominator, which is 1. Okay, so if f of x, so if you have two polynomials, and the degree of the polynomial that's in the numerator is greater than or equal to the degree of the polynomial that's in the numerator, then that means that when we do long division, we're going to have a quotient. So you're going to have a quotient. So you'll be able to write this. So whenever the degree of the numerator is greater than or equal to the degree of the denominator, you can rewrite this right here as a quotient plus a remainder divided by the divisor. Okay? So, all right, so if the degree of the numerator is greater than or equal to the degree of the denominator, then there exists a unique polynomial, and we're going to call this q of x, and I'm going to let's just go ahead and use lowercase q. So q of x, that's a q here, q for quotient, and remainder and a remainder, so let's call that r for remainder, so a polynomial r of x, such that And basically what I'm going to do is the next thing I'm going to write will be something that looks like this. Okay? So such that, actually, I'm sorry, something looks like this right here. So such that now remember this right here, remember this was your dividend, right? That was your numerator. That was your numerator. And in our problem here, in our example, remember this was f of x and this was d of x. So such that f of x will equal, so that your dividend, so your dividend will equal the divisor times the quotient plus the remainder. All right, so that right here is this. So your dividend is equal to the divisor times the quotient plus the remainder. So that's what this is. Okay. All right. Now, the other thing I want to remind you is this. So remember we talked about this example here. And let me get to that example. Okay. So remember when we did that first example, and when we did that long division, we got a remainder of 0. One of the things we stated was this. So whenever you get a remainder of 0, then that means that x plus 2 divides into this polynomial evenly. Okay, so that's what that means. So this polynomial divides into this polynomial evenly. So that's why you got a remainder of 0. Now that's going to be important when we talk about another lesson soon. That if you get a remainder of 0, then that means that this polynomial is a factor of this polynomial. Okay, so if it divides into it evenly, then that means that this polynomial x plus 2 is a factor of that. And we're going to talk about that again later on. But for our purposes here, don't worry about that. All I need for you to remember is that if you get a remainder of 0, then x plus 2 divides into x squared plus 7x plus 10 evenly. Okay? All right. And it kind of makes sense because note, I just want you to remember this. So if I have, let's do a simple example. If I have 8 divided by 4, so if I do long division, and I'm doing a very simple example, 4 divided into 8 is 2, 2 times 4 is 8, you get a remainder of 0. So remember what that means is if you get a remainder of 0, that means that 4 goes into 8 evenly. Okay, so if it says evenly, that means you get a remainder of 0. All right, so the next thing I want to say is this now. So if the remainder r of x is 0, if the remainder r of x is 0, then the divisor d of x divides into f of x evenly. Okay, so that's what that means. Now, also so this division algorithm can also be stated like this. So the division algorithm can also be written as this. So you have your, and it's going to be this part here. So you have f of x divided by d of x. So f of x divided by d of x is equal to the quotient, so q of x, plus the remainder divided by the divisor. So plus r of x divided by d of x. Okay? All right, so that's the division algorithm. So one thing I need to remember is this. Whenever the degree of the numerator is greater than or equal to the degree of the denominator, then you can write this according to the division algorithm. You can write this as a quotient plus the remainder divided by the divisor. Okay? All right, so that's important. Okay, now let's go ahead and do some more examples like we did in the previous lesson. Okay, so let's do the first example. So the first example, and sometimes the directions will say certain things. Notice that in number 1, it actually says the words divide this polynomial by, well, it says divide. So you have this polynomial in parentheses divided by this polynomial. Okay, so I just want to remind you, another way you can write this is this way as well. So you can say 5x minus 8 plus 4x cubed minus 4x squared divided by 2x minus 1. So the way that this looks means the same thing as this. Okay. Now the next thing I want you to do is I need for you to take out your steps for using long division. So we used this in a previous lesson, and it's in your Canvas course if you need to go back and get it. Okay, so notice number one says this. So number one says you're going to rewrite this in long division problem, and you're going to make sure that both polynomials are written in descending order. And if there are any missing terms, you're going to use a zero term as a placeholder. Okay, so if I look at the numerator, notice that this numerator is not in descending order, but the denominator is. So remember, descending order, when you write something in descending order, you want the largest exponent written first, then the next one, then the next one, and you need your constant written last. Okay? So in the denominator, we're okay with that part because that's 2x to the first and then your constant. But the numerator is not. So I want you to remind yourself that to rewrite it, let's see, the largest term is x cubed, so you're going to say 4x cubed. The next will be minus 4x squared, and then plus 5x, and then minus 8. And so notice you have x cubed, you have an x squared, you have an x, and you have your constant. Okay? And then you have your denominator 2x minus 1. Okay, so remember, you're going to rewrite in long division. So that means this. So you're going to say this. Remember, this is your divisor. Okay, so you're going to say 2x minus 1 divided into, and then your dividend. Your numerator is your dividend. So those words are important. Make sure you know those words. So 4x cubed minus 4x squared plus 5x minus 8. And notice there are no missing terms, so we don't have any zero placeholders here. Okay, and then you do your steps. So the next step, remember, you're going to divide the first term of the dividend by the first term of the divisor. And you're going to place the quotient above its like term. Okay, so that means this. So you're going to take 4x cubed, and you're going to divide it by 2x. And so when I reduce this, 4 divided by 2 is 2, x cubed divided by x. So remember, when you divide like bases, you subtract exponents. So 3 minus 1 is 2, so you get 2x squared. So you're going to place that quotient that you ended up with above the like term. So above the x squared. So that's going to be 2x squared here. All right, now once you do that, and once you find it, then the next step is to multiply that quotient by the divisor. So you're going to say 2x squared times the divisor. So some of you can do this mentally, and that's great. Some of you may need to write it down. So basically what you're saying now is this. You're going to take 2x squared, and you multiply it by your divisor. Okay? And then so you're going to multiply this out, and so distribute. You get 2x squared times 2x is 4x cubed. 2x squared times a negative 1 is minus 2x. 2x squared, sorry. 2x squared. So that goes here. Make sure you align your like terms. So this becomes 4x cubed minus 2x squared. Now, if you're doing this correctly, okay, so if it's working out correctly, then what's supposed to happen is that these, when you do your product, when you take this, multiply by this, the first terms listed better be exactly the same. So 4x cubed, okay? That has to be true every time we do this process. And so now remember the next step. The next step now is to subtract. Now, remember in the previous lesson, we have to be very careful. So when you subtract, you're subtracting this whole thing here. And so some of you can very easily do this in your mind. You can mentally do this. So when you mentally do this, you're saying 4x cubed minus 4x cubed. So you know that's 0. So that will always be a 0 here if you're doing this correctly. Now you got to be careful here though if you're doing this mentally. Negative 4x squared minus a negative 2x squared. So don't make the mistake and say that's a negative 6x squared, because it is not. That is not a negative 6x squared that goes here. Because remember, you're saying this. You're saying, and if you need to write it out, you write it out. You're saying negative 4x squared, subtract a negative 2x squared. Okay, so negative 4x squared, subtract the negative 2x squared. And remember, when you subtract a negative 2x squared, that becomes a positive 2x squared. And so now notice that a negative 4x squared plus 2x squared is a negative 2x squared. So that's what goes here, a negative 2x squared. So if you do this mentally, you got to be careful. You may want to also write it out on somewhere else on a sheet of paper. Now, remember, one of the things we said that some of you may want to do is you may want to write here. Remember, we did this in red before. You may want to write out the equivalent expression for this right here. So the opposite, think of this as opposite. So the opposite of 4x cubed is negative 4x cubed. The opposite of a negative 2x squared is a positive 2x squared. And so now notice 4x cubed and a negative 4x cubed, that's 0. Remember, that's also always supposed to be the case. A negative 4x squared and a positive 2x squared is a negative 2x squared. Okay? And then you bring down your next term, plus 5x. And then you do the process all over again. So the next step would be repeat steps through 2 through 4 until you brought down the last term. All right, so let's go through the process again. So now you're going to do division again. So you're going to take this first term now. So think of this as your dividend, and you're divided by the first term of your divisor. Okay, so you're saying this. You're saying the first term here, so that's negative 2x squared, divided by the first term of your divisor, which is 2x. So when I divide that, negative 2 divided by 2 is a negative 1. X squared divided by x. So remember, you divide like base, you subtract exponents, so that's just x. So that's just negative x. All right, so that's going to go here. Remember, align your like terms. And now you're going to multiply again now. So remember, you're going to take this term that you just put up here. So remember that, write it off if you have to. So you take negative x, which you just got, and you multiply by your divisor, which is 2x minus 1. So some of you can mentally do this. You can mentally do this. Some of you can say, well, a negative x times 2x, mentally, without having to write anything down, a negative x times 2x is a negative 2x squared. Now remember, we said this, if you're doing this correctly, when you do the multiplication, this and this better be the same thing, because they're supposed to cancel out in a little while. Okay? And then a negative x times a negative 1 is a positive x. If you need to write it out, you write it out and then distribute. So negative x times 2x is a negative 2x squared. A negative x times a negative 1 is a positive x. See, that right here is what ended up here. Okay? Now the next step, remember, is to subtract. Now be careful when you're subtracting, because remember, you got to be, just like we talked about here, you may want to rewrite it, the equivalent expression for this right here. So if you do this mentally, you got to be careful. A negative 2x squared, subtract a negative 2x squared. All right, remember what that means. A negative 2x squared, subtract a negative 2x squared. That means negative 2x squared plus 2x squared, which is 0. And remember, that's supposed to be true. That's supposed to be 0 here. They're supposed to cancel out each time. Now be careful here. Don't say this is 6x. If you say this is 6x, then your quotient is going to be wrong and your remainder is going to be incorrect. So be careful. 5x subtract x. That's what you're saying. You're saying this. You're saying 5x subtract x, which means 5x minus x, which is 4x. That's what this is supposed to be. So this right here is supposed to be 4x. If you need to, write it out in red what this is equivalent to. So the opposite of negative 2x squared is a positive 2x squared. The opposite of a positive x is a negative x. And now notice, negative 2x squared plus 2x squared, that's 0. Remember that you're supposed to get a 0 here. 5x and a negative x is 4x. Okay? And now you bring down your next term. And that will be our last term. And then you do the division all over again. So you're going to say 4x divided by, so the first term here divided by the first term here of your divisor, which just gives us 2. So 4x divided by 2x is just 2, because x divided by x is 1. Okay? And so that's going to go here, so plus 2. and then you do the product all over again. So 2 times 2x is 4x. 2 times a negative 1 is a negative 2. Okay? And then you subtract. And now be careful, just like we talked about, 4x minus 4x, that's 0. Remember, that adds up to 0, that adds up to 0, that adds up to 0. Now be careful here. Negative 8 subtract a negative 2. So don't say that's a negative 10. Remember what we're saying. We're saying negative 8 subtract a negative 2. Negative 8 subtract a negative 2. Well, that becomes negative 8 plus 2, which is negative 6. Okay, so if you need to rewrite it in red, you do that. So the opposite of 4x is negative 4x. The opposite of negative 2 is a positive 2. And notice that negative 8 plus 2 is negative 6. All right, and notice there's no other term to bring down, so that's your remainder. Now, one thing I want to remind you is this: whenever you're doing this, and this is going to be your remainder. Notice that the degree here, the degree of a constant, and we talked about this in a previous lesson. The degree of a constant is 0. The degree of a constant is 0. So notice the degree here is 0, and the degree here is 1, right? X to the first, 1. So whenever the degree here is less than the degree of your divisor, you're done. You're done. So that's your remainder. Now remember how we wrote this. So your answer, you're going to say this. You're going to say, and I'm going to go ahead and use this one here. So 4x cubed minus 4x squared plus 5x minus 8 divided by 2x minus 1 is going to equal the quotient. So remember your division algorithm. So remember the division algorithm from the previous page. So your division algorithm, so it's equal to the quotient plus the remainder divided by the divisor. So it's equal to the quotient. So remember, this is a quotient now. So 2x squared minus x plus 2 divided, it's equal to the quotient 2x squared minus x plus 2 plus the remainder, plus the remainder, which is negative 6, divided by the divisor, which is 2x minus 1. Now, I just want to remind you, see this where it says just, and this is a number here, and it's negative? You can also write the answer like this: 2x squared minus x plus 2. Make sure, it's plus 2, and then minus 6 divided by 2x minus 1. Those mean the same thing, okay? All right, so that was number 1. Now, let me just remind you about checking. I just want to check this one. It does take a while to check some of these, so we're not going to check all of them, but let's go ahead and verify that this is correct. So remember, to verify this is correct, we're going to use the division algorithm as well. So your dividend is going to equal your divisor times the quotient plus the remainder. So that's how we're going to check this. All right, so let's check it. So real quickly, so we're going to check. So remember your dividend. Let me go back to that page. So it's important to go back and look at this. Remember, this is your dividend. This is your divisor times the quotient plus the remainder. All right, so your dividend is the numerator. Okay, so 4x cubed minus 4x squared plus 5x minus 8. And I want to see that's going to equal the divisor, which is 2x minus 1, times the quotient, which is 2x squared. So basically you're saying this times this plus the remainder. This times this plus the remainder. So times the quotient, which is 2x squared minus x plus 2 plus the remainder. Okay, so let's see if that's equal, if that's true. So let's go ahead and multiply this part out. So since this is a binomial trinomial, I have to use the distributive property. So remember, the first thing we're going to do is this. We're going to take this term here, multiply by this trinomial. So 2x times 2x squared is 4x cubed. 2x times a negative x is a negative 2x squared. 2x times 2 is 4x. Okay, now we're going to go to the negative 1. Negative 1 times 2x squared is negative 2x squared. Negative 1 times a negative x is a positive x. Negative 1 times a positive 2 is a negative 2, and then we're adding a negative 6. Combining like terms, I get 4x cubed. A negative 2x squared and a negative 2x squared is a negative 4x squared. So far we're good, right? See that? And then 4x and a positive x is 5x. And so far we're good. See, we got it here. And then negative 2 and a negative 6 is a negative 8. All right? So notice that when I multiply the divisor by the quotient and add the remainder, I get the dividend. So what I've done is correct. All right, so that was number 1. Okay, let's look at number 2. Okay, so here's number 2. So the direction says this: divide this polynomial by this polynomial. Okay, so remember, you may want to rewrite it as a rational expression first. You may want to say, rewrite this as 3x to the fourth, and let's go and put this in descending order, which it already is. See, it's already in descending order. So 3x to the fourth plus 2x cubed plus x squared plus 4, and this is already in descending order as well. And so notice this is your dividend. This is your dividend, this is your divisors. Also notice is that you have x to the fourth, you have x cubed, you have x squared, but you see you're missing the x term, right? You're missing the x term. You have your constant, so you need a missing term here, so you need a 0 term as a placeholder. Notice over here as well, in your divisor, you have an x squared, you have your constant, but you don't have your x term. So you're gonna need to write a 0 term for that one as well. All right, so let's go ahead and see how to do this. Okay, so let's do the divisor first. So my divisor, I have x squared plus 0x. So you need your missing term. You need your 0 term here plus 1. Okay, that's important to put that. And then over here, you're going to have 3x to the fourth plus 2x cubed plus x squared. You're missing a term. You got to put it 0x plus 4. Okay? So notice I was missing the x term here, and I'm missing the x term here. All right? Now let's go ahead and do the long division. So remember, the first thing we do is we take the first term you see here, 3x to the fourth, divided by the first term here, x squared. So when I reduce, I'm going to get 3. Remember, when you divide like base, you subtract exponents. 4 minus 2 is 2, so you get 3x squared. Now put that over its like term. So I'm going to put 3x squared here. Once you do that, you're going to take this, multiply by this. Now before I go on, remember, make sure that the degree of the numerator is greater than or equal to the degree of the denominator. So notice the degree of the numerator, the largest exponent you see is 4, and the degree of the denominator, the divisor, is 2. So 4 is greater than or equal to 2. So that means I can use the division algorithm, and I'll be able to write it like this. Okay? All right. So now remember, the next thing you do is going to take this, multiply by this. So 3x squared times x squared is 3x to the fourth power. Now remember, just like we said, this always has to occur. If you're doing this correctly, if you're doing all this process correctly, then this and this better be the same. Because when you subtract, they're supposed to cancel out. Okay? Now, here's the reason why you need this placeholder over here. So 3x squared times 0x is 3 times 0, 0. So, and then x squared times x is x cubed. So this becomes 0x cubed. Okay? All right, so remember 3x squared times 0x. So obviously you know that's going to be 0, because 0x cubed is 0, but you need to actually write out that term. So 3 times 0 is 0. X squared times x is x cubed. So you get 0x cubed. Okay? And then 3x squared times 1 is 3x squared. See, all my terms are aligned. Now the next thing you do, remember, is you subtract. You subtract. Now that's where you got to be careful. You have to be careful. And so what some students like to do is they like to rewrite this expression here. Just rewrite the equivalent expression. So the opposite of 3x to the fourth is negative 3x to the fourth. The opposite of 0x cubed is still 0x cubed. The opposite of 3x squared is a negative 3x squared. And then notice that 3x to the fourth and a negative 3x to the fourth, that's 0. Remember, that's supposed to cancel out. 2x cubed and 0x cubed is 2x cubed. X squared and a negative 3x squared, 1 and a negative 3 is a negative 2. So x squared and a negative 3x squared is a negative 2x squared. And then you bring down your next term. So 0x, so plus 0x. And then you do the division all over again. Okay, you do division all over again. So 2x cubed divided by x squared will give us 2x. X cubed divided by x squared, 3 minus 2 is 1. So you get 2x. So I'm going to put that here. Okay, so see, that's why you needed that missing term. So you can align, so you can do this alignment so you don't mess up. And then you multiply. 2x times x squared is 2x to the third power. And remember, if you're doing this correctly, this and this better be the same, just like these were. See that? Okay. 2x times 0x. And think about what we're doing here. 2x times 0x. 2 times 0 is 0. X times x is x squared. So you get 0x squared. So plus 0x squared. Okay. And then 2x times 1 is 2x. Okay. Now remember, the next thing you do is subtract. Just make sure you do it like this. You don't mess up. And then if you need to write it in red, you write it in red or whatever color. It could be the same ink you're using now, same pencil. Just rewrite the equivalent expression. It does help. The opposite of 2x cubed is a negative 2x cubed. The opposite of 0x squared is still 0x squared. The opposite of a positive 2x is a negative 2x. See, sometimes it's harder to do this mentally by saying this. For example, 0x squared minus 2x, some students would still say that's 2x, but it's not, right? Because notice 0x and a negative 2x is a negative 2x. All right, so let's go through the process. So 2x squared minus 2x cubed means the same thing as 2x cubed. I'm said 2x, I'm sorry. 2x cubed minus 2x cubed means the same thing as saying 2x cubed and a negative 2x cubed, which is 0. So just like this, these are supposed to, every time you do this process, every time you do these little groupings, the first terms always have to cancel out. A negative 2x squared subtract 0x squared means the same thing as saying negative 2x squared plus 0x squared, which is still negative 2x squared. 0x subtract 2x means the same thing as saying 0x and a negative 2x, which is a negative 2x. And then you bring out your next term, which is our last term. And then you do division all over again. So negative 2x squared divided by x squared will give us, remember, x squared divided by x squared is 1, so negative 2 times 1 is negative 2. So that goes here. And then you do the multiplication. Negative 2 times x squared is negative 2x squared. Now remember, if you're doing this correctly, see those two would be the same, right? Just like these were. Negative 2 times 0x. Negative 2 times 0x. Negative 2 times 0 is 0, so that's just 0x. Okay? And negative 2 times 1 is negative 2. Now we're going to subtract. Now again, if you need to, just write it out in red. The opposite of negative 2x squared is a positive 2x squared. The opposite of 0x is still 0x. The opposite of negative 2 is a positive 2. And then you add them. So negative 2x squared subtract a negative 2x squared means the same thing as saying negative 2x squared plus 2x squared. That's 0. A negative 2x subtracts 0x means the same thing as negative 2x plus 0x, which is negative 2x. Positive 4 subtract a negative 2, you got to be careful, means positive 4 plus 2, which is 6. And that's your remainder. So let's talk about the degrees again. So you remember, you got to look at the degree of this. So what's the degree of this that I have here? The degree of this is 1. What's the degree of the divisor? 2. Since the degree here is now less than the degree of the divisor, that's your remainder. And notice you don't have any more terms to bring down, right? Okay. So remember how to write this. So your answer, you're going to say this. you're going to say 3x to the fourth plus 2x cubed plus x squared plus 4 divided by x squared plus 1. So that coming from here is going to equal your quotient. Your quotient. So remember, what we're using is this now. So your dividend divided by your divisor will equal the quotient plus the remainder divided by the divisor. So the quotient is this. So that's 3x squared plus 2x minus 2 plus the remainder, which is negative 2x, plus 6 divided by the divisor, which is x squared plus 1. And there's your answer. Okay? That's all you do. All right, so that was number 2. Let's do one more. Let's look at number 3. So number 3. So let's look at number 3. And let's do one where we have to put some missing terms. All right, so number 3, let's say we had this one. So we have 2x to the fourth plus 4x cubed minus 5x squared. Well, that's not the one. I'm sorry. That doesn't have any missing terms. Excuse me. Let's do this one. Number 3. So m to the second power minus 8m minus 9 divided by m squared minus 9. All right. So notice that I don't have any missing terms in the numerator, but I have a missing term in the denominator, right? So I'm missing that 0m. Okay. So it's already in descending order in both cases. So let's go ahead and do the long division. So I'm going to have m squared plus 0m. So you're missing the m term, right? And then minus 9 divided into m squared minus 8m minus 9. Okay? All right, so let's do the division. So now we take the first term here, which is m squared, divided by the first term here, which is m squared, and you get 1, right? You get 1. So that goes here. So that makes you, since that's a constant, make sure you put it over the right place. So that's 1. 1 times all of this. So 1 times m squared is m squared. So remember, you do this correctly. Those are supposed to be the same. 1 times 0m is still 0m. 1 times a negative 9 is a negative 9. Right? Now we subtract. Now when I subtract, I get this. M squared minus m squared, that's 0. A negative 8m minus 0m is still negative 8m. Now be careful here if you need to. See, some of you are going to say that that's negative 18, right? Make sure I wrote this right before I go on. Okay. Just verifying I wrote this correctly. Yep. Okay, so I wrote this correctly. All right, so you're going to say this negative 18, but you got to be careful. So if you need to rewrite it in red, you write it in red. So the opposite of m squared is a negative m squared. The opposite of 0m is still 0m. The opposite of a negative 9 is a positive 9. So what I want you to notice is that this is 0. Negative 8m minus 0m means the same thing as negative 8m plus 0m, which is negative 8m. A negative 9 subtract negative 9 means the same thing as negative 9 plus 9, which is 0. So when you subtract this from this, all you get is negative 8m. And notice there's no terms to bring down, right? No terms to bring down. And notice that the degree here is 1. The degree of your divisor is 2, so that's your remainder. And so your answer then will be, so let me go ahead and rewrite this right here. So you get m squared minus 8m minus 9 divided by m squared minus 9. And so you're going to get 1 plus the remainder, negative 8m, divided by your divisor, which is m squared minus 9. And go ahead and write as m squared minus 9. Don't put that 0m when you write your divisor. You use that number you have, that polynomial you actually have in your original problem. Now, what you know, see how this is just a monomial here and it's negative? So you could have written this as 1 minus 8m divided by m squared minus 9. Does not matter. Those two mean the same thing. So that was a quick one. So we still have time to do one more. So let's do one more. So let's look at number 4. All right, number 4. And let's say number 4, we have this one. We have x to the fourth minus 14 divided by x minus 2. Okay? So notice that remember this is your dividend, this is your divisor. Notice that dividend, in my dividend, I'm missing an x cubed, right? And I'm missing an x squared, and I'm missing an x, correct? So there's three missing terms here. So if you want to, you may want to rewrite it first. You may want to say, well, that's x to the fourth plus 0x cubed, right? Plus 0x squared, missing x squared, so you got to put that 0 term. I'm missing an x, so I got to put that x term, and then minus 14, which is your constant. And then notice that I'm not missing anything in the denominator, so your divisor is fine. There's no missing terms, and it's already in descending order. So now let's use long division. So I'm going to say x minus 2 divided into x to the fourth plus 0x cubed plus 0x squared plus 0x minus 14. All right, so let's do long division. So x to the fourth, so the first divided by the first. So x to the fourth divided by x is x cubed. So make sure you put them in the right place. Then you're going to multiply this times this. So remember, if you need to, write it out. So many of you can do this mentally. And even if you do it mentally, just be careful. You can easily mess up with your signs and with your exponents. So be careful. You can easily make mistakes there. Even though you know the process, and even though you have experience with this and you're pretty good at this, you can still easily make a mistake. So always double check. So that's x cubed times x minus 2. And if I distribute, x cubed times x is x to the fourth, and x cubed times a negative 2 is negative 2x cubed. So that goes here. So notice I have x to the fourth minus 2x cubed. Okay? Now be careful. So remember, the next step is to subtract this now. So you subtract this from this. So if, and remember, if you do this correctly, these two are supposed to be the same. So when you do that product, if this is correct and you do that product, this first part here, each time, it's supposed to be the same. So what I mean is this. So if you go back, always same, same, same. Okay? But be careful here. So some students will make a mistake and say that is a negative 2x cubed, and it's not, because you're subtracting a negative 2x cubed. So remember, what you have here is this. You have 0x cubed subtract a negative 2x cubed. And so 0x cubed subtract a negative 2x cubed means 0x cubed plus 2x cubed, which is 2x cubed. Okay? So you got to be careful. So if you want to, rewrite the equivalent expression right here. So the opposite of x to the fourth is a negative x to the fourth. The opposite of a negative 2x cubed is a positive 2x cubed. It helps. It helps to do that. So, and it helps to do both if you have to. Okay, now let's figure out what this is. So x cubed minus x to the fourth, x to the fourth minus x to the fourth means the same thing as x to the fourth and a negative x to the fourth, which is 0. So remember, always, always, always cancel out, cancel out, cancel out. Okay? Oops. All right, sorry about that. I hit music on the other monitor. Okay, so 0x cubed minus a negative 2x cubed means 0x cubed plus 2x cubed, right? So that's 2x cubed. All right, I'll bring down the next term. Okay, now we do the division all over again. So 2x cubed, I'm going to go and do that here. So 2x cubed, the first divided by the first, divided by x, gives us, remember, when you divide like base, you subtract exponents. 3 minus 1 is 2, so you get 2x squared. So put that here, 2x squared. Make sure you align your like terms. That's important. It helps you to organize all of this information. And now you multiply. Now remember, when you multiply, you better remember this right here better be the same. So just like we talked before, see, before, same, every time you do this. So 2x squared times x. So remember, if you got to write it out, you write it out. There's nothing wrong with writing your information with what you're thinking. It helps. 2x squared times, so this times your divisor, times x minus 2, and then distribute. 2x squared times x is 2x cubed. 2x squared times a negative 2 is a negative 4x. So that goes here. So 2x cubed minus 4x. And again, remember we said this is supposed to be the same because when you subtract, it's supposed to be 0, right? So let's go ahead and talk about subtraction now. Okay, so if you need to, in red, or whatever color you want to use, it helps to actually write out the equivalent expression. The opposite of 2x cubed is a negative 2x cubed. The opposite of a negative 4x is a positive 4x. Okay? So 2x cubed minus 2x cubed means the same thing as 2x cubed and a negative 2x cubed, which is 0. So 0, 0. 0x squared, subtract a negative 4x means the same thing as 0x squared. I meant, that's supposed to be, I'm sorry, that's supposed to be 4x squared right here. 4x squared. Okay, 4x squared. All right, so 0x squared plus minus negative 4x squared means the same thing as 0x squared plus 4x squared, which is 4x squared. And then you bring out your next term. And then you do this all over again. Okay, so 4x squared, we put that here. So first divided by first. So 4x squared divided by x is just 4x. X squared divided by x is x. And so that 4x, you're going to align your like terms, so you put over the x term, and then you do the product all over again. So remember, now you're saying this times your divisor. So now you're saying 4x times the divisor. And then you distribute. So 4x times x is 4x squared. 4x times a negative 2 is a negative 8x. So that goes here. So 4x squared, remember if you're doing this correctly, it's supposed to be the same, minus 8x. And now you're going to subtract. Okay, so be careful you subtract though. So 4x squared minus 4x squared, that's 0. So that's easily seen, but you can easily make a mistake here. So 0x subtract a negative 8x. Remember what you're saying is this. You're saying, I'm going to put that here. You're saying 0x subtract a negative 8x, right? Well, remember 0x subtract a negative 8x means 0x plus 8x, which is 8x. And so if you need to rewrite it in red, you rewrite it in red just like you did these. So the opposite of 4x squared is a negative 4x squared. The opposite of a negative 8x is a positive 8x. And now we combine our terms. So 4x squared subtract 4x squared 0 means the same thing as 4x squared and a negative 4x squared. 0x subtract a negative 8x means the same thing as 0x plus 8x, which is 8x. And now, see, we still have another term, so let's bring it down now. Bring it down. And you keep doing the process. Now, remember, you ask yourself, see, the degree here is 1, right? X to the first, the degree here is 1. So you stop whenever the degree is less than your divisor, than the degree of your divisor. So you say, I can go further. I can go further. So I'm going to say 8x. So first divided by first. So 8x divided by x is just 8 because x divided by x is 1. And so now I'm going to put the 8 here and I'm going to multiply 8 times x minus 2. So 8 times x is 8x. Remember, if you do this correctly, that's supposed to be the same. 8 times a negative 2 is a negative 16. And now you subtract. Okay? And so if you need to rewrite it, rewrite this expression here. So the opposite of 8x is a negative 8x. The opposite of a negative 16 is a positive 16. Okay? And so 8x subtract 8x means the same thing as 8x and a negative 8x. That's 0. So see all this? Cancel, that's zeros. All those are zeros. A negative 14 subtract a negative 16 means the same thing as negative 14 plus 16, which is 2. And notice this is a constant. The degree of a constant 0. The degree here is 1. X to the first, so 1. So you're done. So since the degree here is less than the degree of your divisor, you're done. You found the remainder. So that's your remainder, 2. So your answer, though, you're going to say this. You're going to say the answer is, and I'm going to rewrite the original, x to the 4th minus 14. X to the 4th minus 14 divided by x minus 2 is going to equal the quotient, which is this, x cubed plus 2x squared plus 4x plus 8 plus the remainder, which is 2 divided by your divisor, which is x minus 2. All right, and so that's your answer. That's all you do. And if you want to check it, let's just quickly check this. It's going to take us maybe less than 2 minutes, so let's just go ahead and check this. So if you want to check to make sure what you have is correct, and you remember on a worksheet, you have plenty of time to check. On a test, see how long this took? And you could easily make mistakes. So I know that when you're taking a test, you're going to be checking yourself 2 or 3 times. So you may not want to check in the end, but if you do have time, go ahead and check it. So remember, we're going to go back to the division algorithm. So to check this, you're going to say the let me go back to the actual division algorithm. So you're going to say the dividend is going to equal to the divisor times the quotient plus the remainder. So you're going to say the dividend, which is x to the fourth minus 14, is going to equal the quotient. So this times your divisor. So your divisor times the quotient. So x minus 2 times x cubed plus 2x squared plus 4x minus 8. Oops, sorry, plus 8. And then plus your remainder, which remember your remainder is just 2. So let's multiply this out. So you have a binomial times a polynomial with more than 2 terms. So you have to use the distributive property. The best thing to do is to take each of those terms and multiply by that second polynomial. So x times x cubed is x to the fourth. X times 2x squared is 2x cubed. X times 4x is 4x squared. X times 8 is 8x. Now let's do the next one. Negative 2 times all of this. So negative 2 times x cubed is negative 2x cubed. Negative 2 times a positive 2x to the 2x squared is negative 4x squared. Negative 2 times 4x is negative 8x. And negative 2 times 8 is negative 16 plus 2. So negative 16 plus 2, your remainder. Now let's combine like terms. Have x to the fourth. Now I want you to notice 2x squared, 2x cubed and a negative 2x cubed, that's 0, right? See, you don't have any x cubed terms. Y'all agree? Okay. You see, you don't see any x squareds either, right? So those better cancel out. X to the fourth and a negative 4x, I keep saying x to the fourth, I'm so sorry, 4x squared and a negative 4x squared, that's 0 as well. So you don't have an x squared term. And I don't have an x term either, so those better cancel out. 8x and a negative 8x is 0. I do have a constant. I need a negative 14, and notice a negative 16 plus 2 is a negative 14. So there's your answer. So you did this correctly. So that means that this answer right here is correct. So when you check it, this times this plus the remainder has to equal your dividend. Okay? All right, so that is more practice and more information about dividing polynomials using long division.